Hey everyone, this is Angela Galloway, and this is going to be a lecture session for Math 146, starting our Unit 2 chapter, which is Chapter 13. So this lecture will get through 13.1, hopefully. 13.1 is talking about the time value of money. So I think we all know that money does have a time value, which means that over time you can earn more or owe more, depending on if we're talking about investing or if you're talking about purchasing something. So if we borrow an amount of money today, we will repay a larger amount later. The increase in value is known as interest. The money gains value over time. The amount of a loan or deposit is called the principal. So this is going to be an important term that we will use pretty often in this chapter, especially just looking at some of the formulas we have. If you see a big capital P, then that means we're talking about the principal. So that's the original amount, either the original amount that you borrowed or the original amount that you put into a savings account or something like that. Either of those could be the principal that we're talking about. The interest is usually computed as a percent of the principal. This percent is called the rate of interest or the interest rate. And this is going to be represented by R. Okay, so we call the interest rate is just going to be represented with a lowercase r. The rate of interest is assumed to be an annual rate unless otherwise stated. All right. So let's move on. Those are just some important terms we'll need to know before we actually get into some of our definition or some of our formulas that we're going to have. All right, so the first formula we look at is probably one you've seen before in a math class somewhere along the way, talking about simple interest. So simple interest is interest that's calculated only on the principal. And that's why it's called simple, because it only looks at what that original principal amount was. So the variables we're going to be using here is P for principal, R for the interest rate, and T for time. Now, in most of these formulas, time is represented in years. Okay, that doesn't mean that your homework problem is always going to give you time in years. It means that you need to always convert your time to years. Okay, and we'll show examples of that. But just always be thinking about time. In this chapter, we're going to think of in terms of years. Okay, so once we get those variables, this is what we're going to be solving. I equals P times R times T. Okay, so the interest, the simple interest that we get is equal to the principal times the rate times the time. All right, so let's look at some examples. Find the simple interest paid to borrow $3,500 for 2 years at 6%. Okay, so the first thing we want to do is just identify all the variables, right? So we borrowed 3,500, so that's going to be our principal. We did it for 2 years, so that's our time, and that is in years, so we will plug in a 2 there. At 6%. Okay, so there's one other thing we have to do. We've found the P and the T and the R. However, the R is usually given to us as a percentage, but the way we're going to actually plug it into our equation is to convert it to a decimal. Okay, so a little side note of how do we convert things to decimals. Okay, so if I have 6% here, to convert that to a decimal, what percent means is literally per, P-E-R, cent, C-E-N-T. Now, cent is talking about 100. So percent is saying per 100. So the way we could write this out is we could write it out as 6 and then per, we could do as a fraction 100. So 6 over 100. Okay, now if you put 6 over 100 in your calculator, you should get 0.06, right? So all these things up here mean the same thing. 6%, 6 over 100, 0.06, all mean the same thing. So you can divide your percentage by 100, or you can move the decimal place 2 places to the left. So we always kind of have this imaginary decimal, I guess you'd say, right here that we don't have to put in there because this could be like 6.00%. That's the same as saying just 6%. So what I'm going to do is move this 2 places to the left. like this. And so now any holes I have, I add a 0 in and I would get 0.06. Okay, so that's how I can do that. Now, if you have one of the smaller scientific calculators, it does go back and forth between percentage and decimal. With the bigger calculators, we don't really have anything that does that that I know of, but it's just as easy to remember to always divide by 100. So just do your percentage, always divide it by 100 to get it into that decimal form. Okay, so now that we understand all that, we have all the variables we need. We have them in the form that we need them. So we're going to say the simple interest equals 3,500. That's our P times the rate, which is 0.06, times the time, which is 2, and we get 420. So the interest that we will get, or in this case, the interest we're going to pay over those 2 years to borrow that $3,500 is $420. Find the simple interest paid to borrow $465 for 6 months at 9%. Okay, so we do the 465 times 0.09 because 9% becomes 0.09 when written as a decimal. And then we multiply times 6 over 12. Now, why do we not just multiply by 6? Well, because this is 6 months, right? And I said our time is always going to be in terms of years. So if we're given something in months, then you always are going to write it over 12. Okay, so even if it says something like 18 months, now you could rewrite that as 1.5 years if you wanted, or you can just write it as 18 over 12. Okay, so anytime you're given months, you want to divide it by 12 to get it to years. So 6 months would be like half a year, right? So 6 over 12 will end up being like 0.5. So you always want this in terms of years, okay? So we've got all that multiplied out and we get $20.93. Now, normally on these problems, if your homework doesn't tell you, it usually will say it, but most of the time they want us to round to the nearest cent. And so the nearest cent is 2 decimal places, right? So this would be the penny place there. You deposit $2,000 into a savings account at the bank, which has a rate of 3%. How much total money will you have in the account at the end of 4 years? All right, one of the tricky things about some of the homework problems in this section is that students just don't read correctly what they're supposed to be answering. So there's two different ways we could ask problems about simple interest. We could want to find out how much interest we earn or interest we have to pay, or we might be trying to find out something like this where we're trying to find the total money that we're going to have in an account after a certain amount of years. So that's going to involve an extra step. Both of these just asked for finding the simple interest. This one says, how much total money will you have in the account at the end of 4 years? So the first thing we're going to do is calculate the interest. So the interest is going to tell us how much interest we earned on this $2,000 that I put into the savings account. So we'll have 2,000 times 0.03, that comes from the 3%, times 4 because we had 4 years. And that gives me $240. Now, at the end of 4 years, am I going to have $240 in my savings account? Well, I hope not, right? Hopefully, I'm going to already have that initial 2000 that I put in, right? The 240 is going to go on top of that, right? So now I can add these two things together, and at the end of 4 years, I should have $2,240 in my savings account. Okay, so always double check if you happen to get a homework question, it's counting it wrong and you really think you did it correctly. Go back and look and see, were they asking for the interest or were they asking for the total amount? Okay, because that might be the only thing that you're missing when you're answering your question. Okay. Okay, so this says in example 2, at the end of 6 months, the borrower would have to pay $485.93. So we're talking about this one right here. If we were to see the total amount this person had to repay, well, they borrowed 465, so they definitely have to pay that much back. And then they also have to pay the 2093 back because that's the interest that was earned over those 6 months. So they end up having to pay back $485.93. The total amount to be repaid is called the maturity value, or sometimes often it's just called the value of the loan. Okay, so if you hear them talking about what's the value of the loan, we're talking about at the end of um, the term, how much is actually going to be paid off. How much have you actually paid? Because you're going to, if you're borrowing money, you're going to pay more than what you originally borrowed, right? So it can also be called the future value or the amount, and that is actually the letter that we use for it. So the value we end up calling the amount, which is where we get the A from, and that's what you're going to see in the formulas. The original principal can be thought of as the present value. Okay, so the principal you can think of as the present value. So if you buy a house for $100,000, the present value of your loan is $100,000, right? But after you pay it off after 30 years, then you may have ended up paying, $190,000 for the house or something like that, depending on what your rate was and all that. And that would be the future value. So the future value depends on principal and interest. So if you just want to find the future value, you can use this formula, which is A equals P times 1 plus RT. Now I tell my students that, it looks like, oh, now we have another formula to memorize, but actually this formula is just helping you to do what we did just up here in one step. Okay, so up here what we did was on the prior page we used the simple interest formula to find this. Sorry, that's supposed to be an I there. So this was our simple interest. This was our principal, right, that we had, and we added the two together. So we calculated the interest, then we added it to the principal and got this number. This formula helps us to do all that in one step. So either of these would give us the same answer, whether we do it in two steps or one step, because you'll notice what happens here. When I multiply this in to these numbers, I end up getting P plus PRT, right? P is my principal, plus P times R times T is what? Well, that's our simple interest formula, right? PRT equals I. So if I've already calculated the simple interest, I can add it back to the original principal, and that's what gives me that future value A. But if I'm starting from the very beginning, I might want to plug it in this formula and just get the answer all in one step. So that's all this formula is. It's not necessarily a different formula. It's just showing you how you could do it all at one time instead of doing it in two pieces. So we'll show how to use this formula here. Susan needs to borrow $6,200 to replace the air conditioner in her home. From her credit union, she obtains a 30-month loan with an annual simple interest rate of 5.75. What is the value of the loan? So again, remember, value is referring to the future amount. So the amount there is where we get this A. So A equals P times 1 plus RT equals 6,200. That was our principal. That's how much she's borrowing, times the one's always going to stay a 1 because that's what's in the formula. Okay, so there'll always be a 1 there, plus 0.0575. That comes from the 5.75% converted into a decimal as 0.0575, times 30 over 12. So we had 30-month loan. When we put this in terms of years, we're going to divide by 12 because there's 12 months in a year. So we have 30 over 12. And we put all this into our calculator and we get this, 7,091.25. So let's look at maybe how to put this in our calculator in case you're wondering about that. Oops, I picked the wrong one. Okay, here's my calculator. Now you can do this on just a basic calculator, but I'm just kind of going to show you how to do it like with parentheses. So really, as long as you put the parentheses in direct exactly how it has here, you should be good. Okay, so let's do 6,200, then parenthesis 1 plus 0.0575, and then you can do in parentheses 30 divided by 12, close the parentheses, and then close the big parenthesis here, and then that should be it. And there you get your answer. So if you put it in your calculator just like you have it written out, you should be good. So in your calculator, if you have two numbers beside each other like this with parentheses, it knows that you're wanting to multiply those. So you don't have to put a multiplication sign in there. It will assume that because that's another way of writing. If I put 5 times 2, that's 10. Or if I do 5 times 2 like this, it also does 10. So either way is okay, and sometimes that just saves you time of not having to put in that multiplication symbol if you're already using a parenthesis. So those do mean the same thing. All right. Okay, so we'll go back to this. See what we've got on the next slide. Compound interest is interest paid on principal plus interest. Okay, and so we have a little video here in YouTube that you could watch. And that basically just kind of gives, I like it because it just shows another way of looking at that compound interest. I think sometimes seeing it, in a graphical form can kind of get it to stick in your head about why compound interest is different than simple interest. But what compound interest is doing is every time it compounds, you're getting more money. So each time you get more money, you're calculating your interest based on that larger sum of money. And you do that over and over again. So on simple interest, no matter how long it's in there for, we are calculating our interest in our interest off of the original principal. Okay, so it doesn't matter how long it's in there for, that interest is always being calculated off of the original principal. But compound interest at certain times throughout the year, either yearly, monthly, quarterly, whatever, it's going to calculate the interest on the principal, then add that interest back to the principal. So now you have a larger amount. And then the next time you calculate the interest not just on the principal, but on the principal plus the interest that you've already calculated the time before. Okay, so you're going to get more money back from a compound interest situation than you would from just a simple interest. So simple interest, we have to add in a few more variables because we are looking at, when are we compounding this interest, at what time during the year. So P is still going to be our principal. R is still going to be our interest rate, okay? But we've got two new variables, M and N. So let's see what M and N are going to stand for. So here's our M and here's our N, and this is our formula for compound interest, okay? So it says if P dollars are deposited at an annual interest rate of R, compounded M times per year, and the money is left on deposit for a total of N periods, then the future value A is given by this. Okay, so N is going to be determined by how long your money is actually in the account or whatever. Okay, so that's going to be determined by the actual situation. M, we can kind of look at a few examples of what M might be. We want to know that it's compounded M times per year. So your problem might say that your situation was that it was compounded annually. If it's compounded annually, that means it's compounded one time a year. So M would be equal to 1. If it's compounded quarterly, that means 4 times a year. So your M would be 4. If it's monthly, it would be 12. Okay. If it's daily, rarely you might get one that's daily on some of your homework. They'll tell you how many days to use. Sometimes they say use 360, mainly because that's the number makes it ending it in a zero there makes it a little easier when you're calculating some of the stuff. But it might be 365. It just kind of depends on the problem. But usually we don't have many dailies. Usually we're doing annually, quarterly, monthly. Those are the most common ones. So let's do some examples here. Find the future value and the amount of interest earned for the following deposits. So we've got $12,450 at 3% compounded quarterly for 5 years. So here's our formula, right? The formula we're going to use for compound interest. So the way we know that it's compound interest and not just simple interest is because it says this, okay? If it was simple interest, it would just say $12,450 at 3% for 5 years. There would be no compounding mentioned. But this says that it's compounded quarterly for 5 years. So our principal, of course, is the 12,450, then times 1 plus the rate is 3%, so it would become 0.03 divided by 4. So M is our number of compounding in the year, right? So there were 4 compounding periods because we're doing quarterly, so we divide by 4. Then N is actually the total number of compounding periods over the life of the loan. Okay, so over the entire span of time that we're talking about. So if we're looking at this being in there for 5 years and it's going to be compounded 4 times a year, then we would put 4 times 5 up here. That means there's going to be 20 times that we compound this interest. Okay, so we do it 4 times a year for 5 years, so we would end up with 20 different compounding periods. So that's the N value that we talked about. And then we get 14,456 and $74. So this doesn't just give you the interest, okay? This gives you the end amount, okay? The A, the total amount at the end of the loan. So after 5 years, you would either have earned $14,456 or you'd be paying back that much, just depending on if this is a savings account or if it's something you're borrowing. Okay, so if you did just want to find the interest and just know what's the compound interest going to be, then you would take this number and subtract off the original principal, right? And so that's going to tell you how much you actually earned over that period. So in this case, it would be $2,006 there. So, if the problem happens to ask you that, there's not really a formula to figure out the interest like we had for simple interest. All you do is just assume that, well, if this is the end amount, this was my starting amount, then the difference in the two is the interest that I earned. Okay? All right, B here says $3,419 at 4.1% compounded monthly for 30 months. So I'm going to have 3419 times 1 plus, this becomes 0.041 divided by 12 because monthly, that is going to occur 12 times a year, right? If it compounds every month, there are 12 months in a year, so it would compound 12 times a year. And then we're doing this for 30 months. So up here, when we think about how many periods is this going to be compounded, well, if it's compounded every month, and this is in the bank or wherever for 30 months, then it's going to be compounded 30 times, right? It's going to be compounded in every one of those months there. So that's how we would figure that one out. It's a little different than the other because we're looking at months instead of years, but it's still the same idea of the number of periods over the life of the loan. So we multiply that all out and we get 3787, 38. And again, if you wanted to find the interest, you could subtract off the principal there. Okay, the next example says Kathy invested $3,000 in a savings account with an interest rate of 1.8% compounded monthly. If Kathy makes no other deposits into this account, determine the amount in the savings account after 2 years. All right, so here's our formula. We're going to plug in 3,000 for the principal times 1 plus 0.018. That's for our 1.8% there, divided by 12 because it's monthly, right? Compounded monthly, so that means we divide by 12. And then it's in there for 2 years, so how many months are there in 2 years? 24, right? So we raise it to the power of 24, and we get this answer, 3109.88. Let's talk about how to put this one in our calculator, just in case you're wondering, because this has an exponent in it, can make it a little more difficult. So we're going to do 3,000 times 1 plus 0.018 divided by 12. parenthesis. And then this little thing here, the little, we call it a housetop sometimes, or some people call it like a carrot or whatever. I usually call it a housetop. That means we're going to raise to the power of and then 24. Okay. And then we should get our answer there. Okay, so you want to make sure to put these parentheses in there because that's telling it that this 24, I'm raising just this part to the power of 24, not this. Okay, this whole thing is to the power of 24. So I need those parentheses there to get, my answer correct. Okay, this is a revision kind of the formula that we have. One way we can rewrite it and use it in another way. So notice, of course, this formula is solving for A, right? Well, what if I wanted to solve for P? So what if I knew the ending amount, but I wanted to know the starting amount? How could I find that? Well, the way we do that is we can rewrite this formula, right? I can move things around and basically the way I do that here is I want everything here to move to the other side, okay, because I want P by itself. So I would divide A by this whole thing, and so that's why it looks like this kind of big mess here. But all I did was move this to that side, so I just rearranged this equation, and now I get P equal to A over this whole big thing. So now I can solve for the principal given a certain ending amount. So why would I ever want to do that? Well, here's an example of where you might do that. Let's say you want to save $20,000 to use as a down payment on a house in 5 years. What amount do you need to deposit today at 4% compounded quarterly to have this amount in 5 years? Okay, so let's say you find a savings account that's going to be compounded quarterly at 4%. You know that maybe in about 5 years you're wanting to buy a house and you want to have $20,000 as a down payment. So you could figure out how much you need to put away now so that in 5 years it will be $20,000. Okay? So we're going to plug into this formula because we're not looking for A in this case. We already have A. This is the amount we're wanting to end with, $20,000. We're wanting to find the amount we have to start with, which is the P value here, right? The principal. So we'd say P equals 20,000 divided by 1 plus the rate is 0.04 because we've got 4% divided by 4 because this is compounded quarterly, and then raised to the power of 20. So I got this from here, right here. N is going to be equal to 4 because it's compounded quarterly times 5 years. So there's 5 years. Every year it's compounded quarterly, so 5 times 4 is 20. And then we get this 16,390.89. This one can be a little trickier to put in the calculator, so let's look at that. That's what this kind of shows how to put it in the calculator. Now, why is this one tricky? Well, this one is tricky because you've got this large thing in the denominator. So you want to make sure your calculator knows that this entire thing is in the denominator. So we kind of have to add an extra set of brackets or parentheses here when putting it in the calculator so it knows that 20,000 is divided by all of this, not just by one or this or whatever. We kind of have to have an extra set of brackets down there. So let me get my calculator back up here. So we do 20,000 divided by and then parenthesis. Okay, this first parenthesis is just to say this whole thing is under the denominator, or this whole thing is in the denominator. Okay, the second parenthesis here is just to set apart this to be raised to the power of 20. Okay, so then we have 1 plus 0.04 divided by 4. Close your parenthesis, raise it to the power of 20, and then close your parenthesis here so that you have finished the whole denominator. Okay, so you can see you have 2 left parentheses and 2 right parentheses. So that means all your parentheses are closed. And then that's your answer, 16,039. So sometimes I'll see students do this, 20,000 divided by 1 plus 0.04 divided by 4 to the 20th. Okay? And they're like, why did I get 20,000 again? Well, because what you told the calculator to do was 20,000 divided by 1, which is 20,000, plus this 0.04 divided by 4, which is very small, raised to the power of 20, which just is all basically 0. And so now you've just come back with this. Okay, so you have to be careful. Your calculator doesn't know when you write this that, oh, well, when I wrote that division, I meant I want you to divide this by everything else I wrote after that. That's not what it sees. You have to tell it that with parentheses. Okay, so that can be one little issue when you're putting these into the calculator. Make sure that you are using your parentheses correctly. Okay, so another way I can use my calculator here is using the TVM Solver. Okay, so this is a special application that is in the calculators. There's two places you might find it. If you have a TI-83, like a much older calculator, it might be above this little button here. It might say Finance. This is what I have two different calculators, and one is like this, where the finance is up there. So you would push second and then go to that second, and then the x to the -1, which is the finance, and you should get this screen. If you have a newer calculator, then you will go to apps, so it's probably a purple button there, and mine just has finance on it, so I'll push finance, and then we're going to go to this TVM solver. Okay, so once we get to this step, either calculator should show the same thing. So we're going to go to the TVM solver there. Okay, and so what does this TVM solver mean? Well, we can use this for anytime we're doing compound interest, which also means we'll eventually be able to use it when we're talking about mortgages, and that's where it's really going to be helpful to us. But we can use this for any compound interest formula. Okay, so let me tell you what all these little numbers here, or letters, I guess they are, mean. So N is the total number of times the account is compounded. So this is the same thing as your little n, okay, that you would use in the formula. It's the same thing. The I percent is talking about the interest rate. But usually when we put the interest rate into our formulas, we put it in as a decimal, right? I talked about that for 5 minutes earlier about how we go from the percentage to decimal. Well, in the calculator, we actually write this in as a percentage, okay? So like here, when we see this equals 4, that 4 was 4%, okay? So you do actually put it in as the percentage. You don't convert it to a decimal. PV is the present value, so that's like our principal, same thing as our P, okay? PMT is the payment amount. Now that's really only going to be necessary later on when we do mortgages or car payments or something like that. Right now we're not really talking about payments very much, but that'll come into play later. So for now we just leave that at 0. And then future value. So our future value is actually our A that we use in our formula, okay? And that's the future amount of the loan. Then the PY and the CY, these are the number of compounding periods per year. For us, these are going to be the same number. So if we had something compounded quarterly, then we would put a 4 in there. Okay, so these are going to be our M values that we get from our formula before. Okay, so like 12 we would use for monthly, annually is 1, etc. Okay. Now, sometimes you will get some negative values in here. One of these answers has to be somewhere there has to be a negative because this says right here, negative values indicate what you have to pay or what comes out of your pocket. Okay, so it's assuming that, like a checks and balances thing, you have to have a negative in there somewhere because at some point somebody had to pay for there to be money to come out. Okay, so if you see a negative value, don't let that confuse you that, maybe you did the problem wrong, okay? Just kind of ignore the negative or think of it as, oh, that just means that's the amount I'm going to have to pay, okay? So how would we do this on an actual problem? So let's go back to this one. See if I can get my calculator up. Okay, here's my calculator. So I could do this one on my calculator. Okay, so I'm going to look for what is in. So what's my number of periods there? It's going to be 20, right? So I'll put in 20. My interest rate is 4. The present value is what I don't know, right? That's what I'm trying to solve for. So I'm just going to leave it at 0 for now. Like I said, payment we're not going to use right now. Future value, the future value we want is the 20,000, right? So that's the future amount that we want in there. And then the PY, this is our number of compounding per year, is going to be 4, right? Because 4 is for quarterly. And notice that once you put the 4 in there and arrow down, the other one becomes a 4 as well. And so ours will always be the same, whatever it is for the PY, the CY is also going to be. Because this is actually payments per year and compounds per year, but for us, we're always going to assume that those are the same, okay? All right, so now you have all this in, so how do you get an answer? Well, this, since it's in the application thing, it's a little different than, just typing in what you want and pushing enter. You're wanting this to actually solve this application that it has saved into your calculator, okay? So what we need to do is we go up, you arrow up or down to the part that you want to be solved for, okay? So we want to solve for the present value, right? So I have my little button flashing there. Then I'm going to go to second and wait, no, I'm going to go to alpha and enter. Sorry, I had to look at what this was here. Alpha and enter, when I do that, you'll notice that in green right here, it says solve. So I'm wanting it to solve for this PV, okay? So I'm going to go to alpha, enter, and then it gives me an answer, okay? And so you notice that this answer happens to be exactly what we got here, right? The only difference is that there's a negative. And so what that means in this case is that if you want to get $20,000 out after 5 years, then you need to pay or put in $16,000. Okay, so the negative is just reminding you, you're going to have to pay that in. Okay, but that is our answer, 16,390. Now, do you have to use this calculator part? No. Some students never use the calculator, and that's fine with me. But when I started teaching this class, and I was learning some more about this financial stuff, I was like, I wonder how we can use the calculator for that. And I found this app that is in the calculators where you can do that TVM Solver, and it was just pretty amazing that you can do so much just with this little calculator, especially when we get into talking about mortgages. It's really nice to have this to calculate your payments, pretty quickly. Of course, you can still do it by hand, but what you might do is do some of them by hand and then kind of learn how to use this. And so then on a test or whatever, you can kind of do it both ways and double check and make sure you think your answer is correct, because this actually, ends up being fairly simple to use once you learn what all these variables are talking about. Okay, so that's just another way you can use your calculator on some of these problems. Okay, so that's what, and this is actually the screenshot of what we just did as well. Okay, so another way we could use our calculator, you're generally not going to have a question like this on your homework because it goes kind of beyond what we talk about how to do by hand. So this is not something you would be able to do by hand with anything we've learned. This is just something I'm showing you that, hey, your calculator could actually do this for you. So let's say you want to start a college fund for your new child or grandchild. When they are born, you decide to put $100 a month in a savings account with an interest rate of 8% compounded monthly. How much will you have saved for the child when they turn 18? Okay, so let's fill this in here. So this is a compound interest question because we're talking about this here. It says compounded monthly, right? So if I do put this money away, how many compounding periods are there going to be here in here? Well, it says that it is compounded monthly, right? and then we want them to take it out when they turn 18. Okay, so we're assuming that you're doing this, the first, as soon as they're born. So if you look at how many months there are in 18 years, what you can do up here is you can just do 18 times 12 and push enter, and it does it for you. So 216 months, that's how many times this is going to be compounded. My interest rate is 8. The present value is 0, right? Right now I don't have anything in there. I'm going to be putting money into there, okay? Now this is where we would actually use the payment because I'm saying that I want to put in $100 a month. So my payment is going to be $100. Now why we don't usually use this is on most of our compounding examples that we've been doing, we put the money in there and then we never touch it again. Okay. However, a lot of us don't do that with a savings account, right? We put money in and then we continue to add to it. So this is what you could use, like if you have your own savings account. Let's say you put in $1,000 into a savings account, that would be your present value, and then you decide to pay $50 a month. So you could put $50 there, and you want to know how much you're going to have in there at the end of 10 years. Okay, well, you just need to find your interest rate, find how often it's compounded, and go off of that. All right, and you could calculate it here and figure out how much you're going to have at the end of 10 years. So I'm going to put in $100 a month. Down here, I'm going to change this to what number? 12, right? Because this is compounded monthly. So this is how often it's compounded. All right, so what am I solving for in this equation? What am I going to solve for? You want to know how much you're going to have saved at the end, right? So you're trying to find the future value, which is this right here. So I'm going to go back up to here. I'm going to push my alpha, enter, and it's going to give me an answer. And it's going to say at the end of those 18 years, you will have $48,000, okay? Now this is a negative because I said we were going to be paying $100 and then I'll get back 48,000. Probably what I could have done is if I'm thinking about negatives as something I pay, I could have put in my payments as a negative 100 and then my future value would have been a positive 48,000, but it doesn't really matter too much there as long as you're not worried about that negative being there. Okay, so after 18 years, you had $48,000. So that would be a pretty good gift to your child or grandchild, I would think. Now, these are just some more examples looking at how compounding changes if you do different types of compounding. So we've got annually, monthly, quarterly, and daily. So of course you're going to get the most money from something compounded daily, right? And the least from annually, but annually is still going to be more than simple interest. However, it may not change a whole lot. Like in this case, since it was a fairly small amount of money, over just a short amount of time, just 4 years, you're not going to see that big difference. Now, if we left it in there for 40 years, you would see a bigger difference in annually, monthly, quarterly, and daily. But since it's just for a few years, we don't really see as big a difference. But you do see that there is a difference between all of those. So between annually and daily, there's about $11 difference. The last type of compounding that we talk about is continuous compounding. Okay, so continuous compounding, sometimes we will talk about when we think about inflation or the inflation rate. Okay, and that's what this example is going to be about here. But the way we write out continuous compounding is A equals P times e to the RT. Now, E is actually not a variable that we're going to plug something in for. E is a constant value, and it actually equals out to 2.718, etc. Okay, keeps going and going out there. This is called Euler's constant. Euler starting with an E, it's E-U-L-E-R. So Euler's constant there. That can be found on your calculator here. Now, to get out of this, also do second and quit. Okay, and that will take you out of there because you're actually kind of in a program, so you have to kind of quit it to be able to get out. The E, though, should be here above the natural log there, you see you get the E there, and it always automatically comes up with raising something to the power of that because that's generally how we're going to use it. This is the same E that's used uh, in exponential formulas or functions that we'll talk about later on. But for now, we're just kind of going to gloss over the E, but that is what it stands for. Okay, so it'll always be that. So you're not actually plugging anything in for it. That's just holding the value of this 2.718 for you. Okay, so with continuous compounding, what that means is it's just constantly compounding. So even more than daily, more than hourly, more than by the minute, it's just continuous, okay? So suppose you earn a salary of $34,000 per year. About what salary would you need 20 years from now to maintain your purchasing power in case the inflation rate were to persist at each of the following levels? So it's saying based on certain inflation rates, how much would we need to make in 20 years to feel like we're making the same amount we do now? Because we figure if inflation continues to go up, which it, you know, or have an increase there, we're going to assume that in the future we would need to make more money than we would now. Like they'll look back and say, oh, 100 years ago, this house cost $3,000, but in today's money, that's like 300,000 or whatever. So it's just looking at, the difference in values over time. So this one, what we'll have is 34,000. So that's your salary there. That's your starting amount times E to the 0.016. So that's the 1.6% times 20. So 20 comes from the years because we're talking about T. Again, T needs to be in years. And you get 46,822. So in 20 years, you would need to be making $46,822 to be making basically the same as what you are now at 34,000. So putting this into our calculator, how would we do that? Well, we're going to do 34,000, and then we'll do second natural log, so we get that e to the power of. It automatically has a parenthesis in there, so we're going to do 0.016 times 20 and then close the parenthesis because we want this entire thing to be up in the exponent. See how the R and the T are both small? They're both in the superscript there where they're in the exponent. So you want to make sure that you include them inside the parenthesis so that it knows this whole thing is raised to the power of that. And then there's our answer. And then the next one was saying, back in the 1980, we had a high inflation rate. So that was showing that if that was to persist, you would need to make a whole lot more in 20 years than what you do now to have the same buying power. All right, effective annual yield. We've got APY and then we have APR. Okay, so why do we talk about APY and APR? Well, when we're talking about compounding, okay, if we're compounding a rate over time, okay, and getting uh, our money back from that, over time, that rate is actually going to be higher over time than what the original APR was that was given because we're actually going to get more back than what just the APR said because we're compounding that interest over time. Okay, so for simple interest, the APR or the APY will be the same, but for compound interest, it's going to be different, okay? So a nominal interest rate of R compounded M times per year is equivalent to the following effective annual yield, and that's represented by APY. And so it equals this, Y equals 1 plus R over M to the M power minus 1. So R is our rate, which we call the APR. M is our number of compounding periods per year. Now, why do I want to know this? Well, what if you have the option of putting something in some account that has the APR stated, and then you have another one that gives you the APY stated. How do you know which one is better? Okay, so that's one of the things we try to do in this class is trying to decide which is the best option to go with. We're going to talk about that in mortgages. We're going to talk about that here when we're looking at different savings accounts. So we're trying to decide, how do I know which one is better? So this says that Christine wants to deposit $2,800 into a savings account and has narrowed her choices to the three institutions represented here, which is the best choice. Okay, so you see we've got, let me see if I can erase this real quick so we can kind of look at it real quick instead of having to see all the stuff I already wrote on it. So Friendly Credit Union has a 2.08% annual rate compounded monthly. Okay, so this value here is an APR. So an annual rate is an APR. Okay, the next one is Premier Savings, and it has a 2.09% annual yield. So that's an APY. Okay, the last one is 2.05% compounded daily. So this one also is an APR. If it says that if it gives how often it's compounded, then it hasn't told what the yield is yet. It's just telling the rate. Okay, so just looking at these, just based off of the numbers we've got here, okay, so we've got uh, three different rates to look at, 2.08%, 2.9%, and we've got 2.05%. Okay, so just looking at those three, which one looks like the best rate? You're trying to make more money. This is a savings account, so you want the highest rate possible, right? So it looks like 2.09 would be the best, right? Because it is the highest. However, we can't compare APRs and APYs, okay? We need to look at the APY of all of them to be able to compare them correctly. So you noticed here that we actually already have this one just as 2.09. Okay, it's just set like that. Now this one up here, we're going to figure out what is the annual yield for something that has an APR of 2.08% and is compounded monthly. Okay, so we plug that in here, the 0.0208 divided by 12 because it's compounded monthly, raised to the power of 12 because it's compounded monthly, and then you always subtract 1. That's just part of the formula up here, okay? And that equals 0.0210, which is 2.10%. Okay, so we thought that um, that first one had a 2.08% rate, but actually, since that was the APR, the APY is 2.10%, which now makes it a better choice than the Premier Savings, right? Then the last one, the neighborhood one, is 2.05%. It's compounded daily. We're going to use 365 here for daily. We divide by 365, raise this whole thing to the power of 365, subtract 1, and we get 0.0207, which gives us a 2.07 APY. So that means that the best choice is going to be this 2.10, right? That's going to be the best choice because it's the largest. If we're dealing with savings accounts, we want the highest APY, right? We want to get the most money back. If we're dealing with borrowing money, like for a loan, then we want the lowest APY, right? Because we want to have to pay the least amount of money back. So how can we do this on our calculator? We can actually do this in our calculator as well. So let me pull that up here. So we're going to go back to our apps. Let me turn this on. Go back to apps and go to finance and calculate. And so we went to TVM Solver before, but now we're going to go down here to EFF. Okay, right here. Now, EFF stands for Effective Annual Yield. So that is what we saw. Go back here. Whoops, I'm sorry. Go back here. Notice this is called effective annual yield. Okay, so the EFF, that's where that's coming from. Okay, whoops. Okay, so effective annual yield here, we're looking at how are we going to put this in, okay? So this has on here how to put it in. We want to put the APR in and then comma, the number of times it's compounded in the year. Okay, so pretty simple. So we're going to go here and like for the first example we had, it was 2.05%. And it was compounded, or if we had something that was 2.05% compounded 12 times a year, which would be monthly, then we see the effective annual yield is 2.069. Okay. Um, if we wanted to do another one, we do second, enter, and that always will bring up the last thing that you just typed in. So let's say now we wanted to say, well, what if I have 2.05 and it's compounded daily, so 365? Well, then you can find what that would be. And I think that is actually the problem, the last problem we did, the 2.05 that was compounded daily. And so that's how you can do that using that effective, the EFF, effective annual yield. And so that can make it much quicker than doing that formula every time. So all you have to remember is go to apps, go to finance, and then go down here to the EFF. Okay, and that's going to give you the effective annual yield. So you might be thinking, well, why do we have APY and APR? Because it seems like they basically are telling us the same thing. It's just, um, one is going to be a little different than the other depending on how often it's compounded, right? Well, sometimes it's more advantageous in a situation to use APR, and other times it's more advantageous to use APY. APY is always going to be greater than the APR if we have compound interest, okay? Because we're saying, here's our annual percentage rate, but because I'm compounding it multiple times through the year, what I'm actually going to yield at the end of the year is going to be more than what I would have yielded had I just had simple interest. Okay, so compound interest is going to make that APY higher than the APR. Simple interest, the APY and the APR will be the same because it's an annual yield is going to be the same as what your annual rate was, okay? If a bank is advertising a savings account, then they'd probably want to tell you about the APY because that's going to show that you're getting a higher rate of return. If they're advertising a loan, then they'll probably advertise the APR because customers want a lower rate, so they're going to want to see that APR. So for example, 5.25% APY is the same as 5.13% APR. Okay, and here is I'm trying to think what that is. Oh, I think this was just an example showing the difference in APR and APY in a real life example. So if you want to click on that, you can see that example there. And so then I just pulled some examples that I found just on the internet, different web pages about how that is true about the APR and the APY. Okay, so notice both of these. This is for, I don't know which loan this was for, but we're talking about loans, auto loans. And so notice that they give the APR, okay? Now you're borrowing the money, right? You're going to end up paying the APY, paying back that APY, but they're telling you the APR because it's going to look lower than what that annual percentage yield is. The same thing here, okay? For US Bank, they've got some auto loans available here and they show the APR, okay? But again, the APY is going to be higher, but they're probably not going to show that because they want you to think about the APR instead of the APY. And then the opposite of that is now we're looking at savings accounts. So here we're looking at a savings account by a bank here, and it says 3.5% APY. So this is giving the APY. The same thing here, looking at this CD special, they're giving a 2% APY. So Why do we need to know this? Well, just be aware of that. If you're given different options, look for if they have APRs or if they have APYs, okay? If they have APYs, then you can compare all APYs. You can't compare every APR unless they were all simple interest or they're all being compounded the same amount of time. So if they're all compounded monthly or quarterly or whatever, then you could. But if you've got an APR that's compounded monthly and another APR that's compounded quarterly, then those are going to come out to different APYs. So the APY is what you would want to use to compare different options to be able to tell which one's the best. All right. Okay, so I know I went through a whole lot of stuff. You may not have even been able to sit through this whole one um, all by itself because it was really long, but that is the end of section 1, and I will make another video for the rest of the sections for chapter 13. So chapter 13 is our unit 2 assignments, and this is just the beginning of it. So I will get to working on the other ones. If you have any questions, please email me and let me know, or you can always click the Ask My Instructor button on the My Labs as you're working on your homework assignments. All right, thanks.